Hi everyone, I'm Sandy Elsom and welcome to this lecture on artificial intelligence. AI is a field of computer science that focuses on teaching computers to do things that normally require human intelligence, so like recognizing patterns, understanding languages, or making decisions. We all use AI all the time. It's how your phone recognizes your face to unlock, or how Siri answers your questions. But the release of ChatGPT has really pushed AI to the front pages of the news media. I know a lot of people are excited about it, some are worried, and some are scared. In this lecture, I'd like to help you understand what AI is and how we can use it in our daily lives. I'm also going to talk about how it works and, importantly, how AI has no concept of truth, which is particularly interesting in a university context. Finally, we'll look at how AI may impact industry, particularly the technology industries. Because this topic is somewhat above my skill level, I've called on my technical advisor, Haziq Nordin, to help me out.
So my name is Haziq. I'm a software engineer at Amazon. I've been there for almost 5 years. I initially worked on their grocery business, and then now I'm working in counter-terrorism financing and anti-money laundering. Before Amazon, I was very interested in research. So I did a bit of work with the Queensland Brain Institute. I did a bit of research with them into zebrafish and how we can use neural networks to better understand them. I worked with a startup with some guys from the CSAIL lab at MIT for how we can use neural networks to understand accents and detect accents and detect what part of a person's pronunciation is sort of indicative of an accent for people who are interested in language learning. It's been a while since I've worked with AI, and I've sort of been watching things happen with great interest, particularly this newer work with generative AI.
So Haziq mentioned neural networks. A neural network is like a computer brain. It's a type of artificial intelligence that is designed to work and learn like the human brain. Imagine you have a brain with a bunch of interconnected neurons or brain cells. Each neuron receives information from other neurons, processes it, and then sends it to other neurons. This network of neurons is what helps you think, learn, and make decisions. A neural network works the same way. It has a series of interconnected nodes or artificial neurons that receive information, process it, and then send it to other nodes. This network of nodes can be used to solve complex problems and make decisions just like the human brain. For example, a neural network can be used to recognize patterns in images or to translate languages. It can be used to predict outcomes like the stock market or the weather. The more data it gets, the better it gets at recognizing patterns and making predictions. A bit later, we'll talk more about neural networks, but before that, I want to give you some sense of how AI might be useful to you right now in your everyday life. Haziq has been experimenting with AI, and so I asked him to outline how he's been using it.
So recently I've been thinking about picking up a house, and I wanted to buy somewhere where it needed a little bit of renovations. Like I didn't want to have to do anything structural, but I wanted to be able to do some cosmetic work because I've done a little bit of renovations before. I've really enjoyed it, and it sort of seemed like a fun thing to do. So I was sort of thinking about it, and I was like, okay, what if I sort of take things to the next level? So far I've only just sort of built decks and put up some non-supportive walls and ripped up carpet and put down floorboards, that sort of thing. What if I wanted to take things further? For example, how would I be thinking about this if I was a builder and I was getting a house? Obviously the kinds of renovations I'd be considering would be very different because I'd be able to actually build a lot of this stuff. So there's kind of two major parts to that, right? The first part is sort of just the trade skill, so woodworking, and I don't know anything about woodworking. I've never done woodworking. And the second part of that is interior design. So aside from just being able to put the things together, I sort of need to be able to reason about what looks good and what doesn't look good, and how do I deal with colors and space and so on, which again, I know nothing about. So I decided to see if an AI could help. And so what I did was I sat down and I had a long chat with an AI and sort of thought about, what information would be helpful for this AI to sort of be able to help me. So I told it, I can do some software, I can do some robotics, I can do some 3D modeling. Don't really know anything about woodwork, so that's a bit tricky, but I kind of want you to tell me about the things I could do in woodwork that would sort of use the skills I already have. Like, it might not make sense for me to learn how to do carving, for instance, if I can already do 3D modeling. I want to kind of take all this stuff into account. And the AI did something very impressive, which is that it suggested that I, rather than build everything and sort of learn the difficult skill of learning how to, be precise with wood and so on, is since I can already do 3D modeling, like how about I just get a CNC, which is like a device that you can program that can just sort of cut shapes for you, and it can cut shapes out of metal and wood and so on. How about I get a CNC and then I can use my 3D modeling skills and put together the furniture that way. So that way I'm not sort of having to learn everything from scratch, which was really insightful. Like that's a really clever, insightful suggestion that would not be a thing I could easily find on the internet. And then there was a second problem, which is interior design. So I don't know anything about interior design, and initially, I would chat to the AI and say, hey, like, can you explain some of the concepts to me? Can you sort of summarize this massive field for me to make it sort of productive for me to start to search? So, like, in approaching sort of a new topic, a lot of the time, the difficulty is that you just don't really know what the words are, you don't really know what's important, what the concepts are. So I thought, you know what, like, let's just get the AI to sort that out. Like, just tell me what the general concepts are. This is kind of what I'm interested in doing. So, like, I don't want to know everything about interior design. I just kind of want to know what's specific to the thing I'm trying to do. And, presented some concepts to me about space and balance and how do you deal with color and how do you sort of establish a motif and so on. And I was like, okay, this is really useful, but it's still kind of theoretical for me. And this feels like the sort of thing I need to be able to see. So what I did was I pulled up another AI and I spoke to that AI and said, hey, like, I'm using this other AI that can generate images for me, but it needs a prompt and it needs that prompt to be really specific. So, you've kind of explained all these things to me, and I want to get a rural house in like sort of rural Australia. So can you sort of apply these concepts to a house and kind of describe what that would look like, given like these are the things I'm interested in? And can you do that in a way that would allow this other AI to know what to draw? And it was able to do that. So it put out like several descriptions, and then I just put it into the other AI, and the AI went and did all the things and came up with these beautiful designs, which was remarkable because I wasn't actually able to describe what I was trying to achieve in terms of interior design. Like, I think inherently I kind of knew, but I didn't actually know what this thing was going to look like. And well, what I would have done before is probably get an interior designer who would have gone through this entire conversation and slowly tried to figure it out, but it would have taken quite a while, and this entire process took about an hour. And yeah, so here are the designs. You can sort of see here that more than just proposing some kind of candidate designs that would sort of make sense in the context of like a rural house, it was able to incorporate some pretty difficult constraints. Like the house that I'm going to buy is probably going to have pretty low ceilings. It was able to incorporate those low ceilings. I wanted to make things mostly out of wood. So it was able to sort of suggest what that furniture could look like. And even more than that, sort of suggest furniture that I could sort of reasonably build on my own. And it looks like we can just sort of do that now, which is insane.
Let's review the process that Haziq used. First off, he had a particular need in mind. He wanted to buy a house and save money on the renovations. But he lacks woodworking skills and he doesn't know anything about interior design. So he identified the skills that he already had: software development, robotics, and 3D modeling, and he gave that information to the AI thinking that it would teach him how to advance his woodworking skills. Instead, the AI suggested that he get a piece of machinery that he hadn't considered that would allow him to apply his existing skills to this new problem. For the second problem, interior design, Haziq put his likes, dislikes, preferences and ideas into the AI, who was then able to describe those ideas clearly enough that a second AI program could create images. And all of this in 1 hour. Let's hear more about these tools.
There were two AIs that I use. So the first one is called ChatGPT and the second one's called Dall-E. And these are both AI that have been created by a company called OpenAI, which is a not-for-profit whose explicit charter is to build ethical AI and help us sort of deal with the many challenges that AI will eventually pose to society. The actual underlying algorithm for both of them is the same. They're very, very simple algorithms, but without getting into the math, they can be a bit tricky to describe. So instead, what we're going to do, I think, is look at a particular kind of neural network called a convolutional neural network, which is a kind of neural network that's great for working with images. But they're also great because they kind of allow you to visually reason about what a neural network is doing. So as you can sort of see from this image, it's performing a series of calculations. You almost have like layers of calculations where the initial calculations extract concepts that are a bit more basic, like it looks like this initial layer is dealing with what's a line and what's an edge, and then it's sort of the subsequent layers build on top of those sort of base layers to say, like what's a shape, like what are some basic shapes, and the subsequent layers will deal with combining those basic shapes into sort of more complex shapes, and the subsequent layers will kind of combine these complex shapes into something that looks like concepts, and then they finally kind of come together to work out what a thing is. So why are neural networks so powerful? It's not so much the computation that it's doing here that's the powerful thing. The powerful thing is how you can arrive at an algorithm that's able to discern what this is, and what's difficult about that. So I guess there are two things. The first thing is you can sort of see that this neural network is dealing with some very non-obvious concepts. It's dealing with some like kind of intermediary concepts that we probably are able to intuitively reason about but can't easily define. So what these base concepts are isn't obvious. How to order them isn't obvious. How many concepts you need isn't obvious. Given what you have, how do you combine them? Like these are all sort of non-obvious things, and also these are almost like constants that you have to like sit down and define. Which if you had a person sit down and do it, it would be really, really hard for them to exactly define what all the rules are to for example, detect what a giraffe is versus a tree. Neural networks are powerful because they provide an algorithm that allows the AI to just self-learn these concepts just by being shown examples of inputs and what a correct output would be. So, for example, lots of random pictures and pictures of giraffes, and you can slowly teach it to, just by showing it examples of things that aren't giraffes and things that are giraffes, how to sort of reason about an image and eventually sort of provide that sort of output. And it uses something called backpropagation to do this. Like again, that's just like a very niche math thing, but the algorithm is a very, very simple one. There's also some clever mathematics that you do that prevents these AI from just memorizing, essentially just rote learning the answers. So what you don't want is for it to only be able to identify giraffes in images that you've shown it before. What you want it to be able to do is, given a new image with a giraffe in it that it's never seen, like kind of figure that out. And there's some clever math you can do there to make it do that. There's also some clever maths to help the AI progressively reach a right answer. So that's an entire field of mathematics, of working out cost functions and so on. But essentially that's what this AI is doing.
There were some complicated terms in that explanation, so let's review them. Haziq talked about a CNN, or convolutional neural network. A convolutional neural network is a computer program that's used to recognize patterns in pictures. So as you saw, it does this by looking at the image through many small windows, called filters, to pick out important features. The filters move across the picture looking for things like edges, shapes, and objects. The information is collected from the filters and used to classify the image as a dog or a tree or whatever. The CNN learns from lots of examples to improve its accuracy over time. He also explained that the CNN uses backpropagation to fix its mistakes. When the CNN tries to classify an image, it makes a guess and then it compares the guess to the correct answer. If the guess is not right, the backpropagation process goes backwards through the network and adjusts the values used to make the guess so that the next time it will be closer to the correct answer. This process is repeated many times to continually improve the accuracy of the CNN. So to use ChatGPT effectively, there are two important skills we need: the ability to ask the right questions and the ability to find out whether the output is true.
Okay, so now we roughly know how ChatGPT works, we can start to kind of reason about what it can and can't do. And I'll focus on ChatGPT because that's sort of the exciting thing that's happening right now. So what it has done is it's read a bunch of high quality text and conversations and broken them down into base concepts such that it can kind of productively produce new text using those concepts, which is really powerful and really cool. But what it can't do is actually validate that any of that is true. So it doesn't have a concept of truth, it only has a concept of does this make sense in the context of what I've read before, which sounds similar to truth, except it's missing the crucial element of validation. This can manifest in pretty weird ways, like sometimes it will just make things up that look right, but it just totally made up. For example, if you ask it to write a program, sometimes it uses some concepts that don't really actually exist in programming. If you ask it to add references to a paper, sometimes it'll just make some references up which don't actually point to anything. Which is obviously not what you want. These aren't inherent limitations. There's nothing in theory that would prevent an AI from being able to weigh these different resources and provide references in the way that like the human might. Really, the big challenge there is how do you collect that data, which I'm sure is something that many companies are working on right now.
It doesn't have a concept of truth. That's pretty important. Let's have a look again at these AI images that Haziq showed us earlier, the interior design ones. Once you look closely at these images, you can see that some things just don't make sense. What exactly is this here? What is this item on the couch? What about these lights here? Where would the ceiling have to be for that to make sense? Sometimes the oddities are hardly noticeable. But because it has no concept of truth, AI doesn't just get details wrong, it can make them up completely, and this is called an hallucination. Hallucinations are most easily demonstrated by looking at visual imagery created by AI, but AI can hallucinate in text as well. Here is a list of suggestions that ChatGPT returned when I asked for resources where I could read more about a particular research methodology. Looks impressive, hey? Well, I'm sorry to tell you that these books and articles do not exist. The journals themselves are real, but the topics, titles, and authors are hallucinations from ChatGPT. Now let me take you back to something else that Haziq said. It only has a concept of, does this make sense in the context of what I read before, which sounds similar to truth, except it's missing the crucial element of validation. The validation is up to the user. We have to check that the information that ChatGPT gives us is true. And as you can imagine, that is particularly significant for anyone who wants to use ChatGPT to help with academic tasks. At this point, you might feel like you'd rather avoid this technology completely. You may feel that you could do a better job by yourself, and you might be right, but...
Cool, so where is ChatGPT going to sort of fit in everyone's workflow? So I think there's an easy trap to fall into here. And that trap goes something like this, which is, ChatGPT isn't as good at writing software than a good software engineer, so we just shouldn't use it at all. I think that's really silly, and I'm going to explain why I think that's silly by using a historical example, which isn't my example. It comes from Clayton Christensen, which is...
The story that Haziq told me was the story of the integrated steel mill versus the mini mill, which Clayton Christensen used to illustrate the concept of disruptive technologies. I'm going to give you a link to read this story or watch a YouTube video about it. Basically, Christensen introduced the idea of disruptive technology, which refers to a new technology that comes along and changes the way things are done, disrupting the existing market by reaching new customers. Disruptive technology is not the best technology. The market leaders aren't interested in it because it's not as good as the leading products, but it's cheaper to access and easier to use. A disruptive technology is taken up by people who don't need to be at the top of the market, they just want to be in the market. And then, as the product improves over time, it works its way up the customer base until the previous market leaders get pushed off the top. Artificial intelligence is a perfect example of a disruptive technology. AI is changing the way businesses operate and interact with their customers. With AI, companies can automate many tasks and make their processes more efficient. AI systems can analyze large amounts of data, making it easier to make informed decisions and provide personalized experiences to customers. For example, AI-powered chatbots have disrupted the customer service industry. They might not be as good as a trained human customer service assistant, but they provide quick and convenient access to customers 24/7 without the need for human support. This has not only improved customer satisfaction, but also reduced costs for businesses. I asked Haziq about where he thinks the technology might go from here.
So it kind of feels like we've hit like a watershed moment in AI, and I think it's fun to speculate about where things are headed. So one thing we know for sure is that big tech can definitely smell the opportunity, and they're all swarming to build out more powerful models with more data, and that's going to be a pretty expensive project. So to train one of these AI, just the computation can, you can be looking at something in the order of millions of dollars just for the computation. So that's not counting the engineers, that's not counting the data labeling, just the computation. So what that probably means is that that's mostly going to be the domain of big tech. The barrier of entry is pretty high to sort of build out these models from scratch. So there used to be a time where labs were able to reasonably do this, but the data sets are very quickly getting a little bit too large, and the amount of computation you need is very quickly getting a little bit too large. That's not all bad news. I imagine big tech will take a similar approach to what it did with cloud computing, which is essentially providing these raw elements that are normally really quite expensive to work with, and providing them for other people to be able to build their own AI on top of using something called transfer learning. So to explain transfer learning, we can sort of return to the example of the convolutional neural network. So, I was talking before about, this thing's trying to learn how to identify a giraffe. Now, I'm not sure if that's exactly what that neural network was trying to do, but you can sort of see that many of the base concepts like edges and lines and shapes are useful for more than just working out what a giraffe is. Some of these base concepts are useful for working out what a tree is and what a television is and what a car is as well. You can almost sort of work out what other things are without having to relearn all those concepts and doing all the computation required to get an AI to learn those concepts. So transfer learning is really about taking some of the earlier layers that have sort of been like pre-trained by someone else and training and adding some computation at the end that allows it to learn how to do different things. So you can almost like tack on some later computation that uses the previous computation that was really quite expensive to tune. And this is really cool because it makes it affordable for smaller players to build really powerful AI without needing to recompute everything. So rather than looking at a cost of millions and millions of dollars, you'd be looking at maybe a couple of hundred, maybe a couple of $1,000s. And it means that the cost to build all that initial thinking just kind of has to be paid once. So what it means is that sitting underneath all the work that big tech is doing is probably going to be some room for a cottage industry of companies who are interested in kind of retraining these more powerful AI to do more specific work. For example, you might have a company that just builds AI on top of ChatGPT that's able to reason about nutrition science or law or software engineering and deal with the unique constraints that these different fields have. So for example, in nutrition science, you probably kind of want a lot of references. For law, you probably want a lot of references in the way that lawyers might need to provide references. And for software engineering, you probably need some mechanism to be able to test it and actually run it in a sandbox, for instance. And these are things that you can later build and you can use sort of like the base concepts that have been learned by this bigger AI to eventually do, which I think is going to be insane and really cool.
Haziq works in industry, not in academia, but he has some familiarity with the system from being a student and from working in a research team, and he's an employer. So I asked Haziq for his thoughts on how universities could approach the use of tools like ChatGPT.
Plagiarism. I'm not an educator, obviously, but I would proceed with caution here, and I think a thing that would be really heartbreaking to see would be because ChatGPT can start generating some pretty workable essays and it can do things like pass the bar and do well in medical examinations, for academia to respond in probably the most lazy and short-sighted way possible, which is to say, oh, no more computers then, people aren't allowed to use ChatGPT, we don't want them to cheat, and I don't want to change my thing. I don't want to change my thing because it's inconvenient and hard for me to think about difficult problems. Therefore, I'm just going to make it hard for people to use the right tools for the job. I think that would be devastating. I think that would be a real disservice to the students. I think it would also be a disservice to the people that are doing it, because I think it's a lazy and uncreative way to deal with technology. What I hope to see, and what I hope will happen, and what I hope to see in future engineers that I work with, is a generation of engineers that have grown up with this tool and are able to use this tool and are a lot more fluid with this tool than I could ever hope to be, to accomplish things that would be really, really difficult for me to do because I didn't have this woven into my education. I think that would produce a generation of engineers that are extremely, extremely effective. And I think to get them there, I think it's important to be open-minded about what work looks like in the light of tools like this, and to be flexible in the way we measure that and the way we assess that. And I don't have any easy answers, unfortunately. I have some theoretical answers, but I don't think they're particularly helpful. But what I would hope is that the people that are working on this problem are thinking about it in terms of how do we make it so that our students are more capable than we could have made them before these tools existed. Instead of sort of trying to bury them until they can finally escape from your class and finally use the tool, because at that point it would have been such a wasted opportunity, and I hope we don't see that happen.
Before I finish this lecture, I'd like to tell you how I used ChatGPT to help me create this lecture. Initially, I asked the software what I should include in a lecture for students to teach them how to use ChatGPT responsibly and as a resource instead of trying to use it to cheat on their assignments. This is the output that it gave me. Not all of these items are included in this lecture because I'm also building a workshop that we'll do in class, but this helped me to work out which main points were important. I asked ChatGPT some basic questions about itself, including why it hallucinates. I also asked for further explanations of some of the concepts that Haziq spoke about. When I didn't understand, I asked the AI to rephrase its response at a Year 12 reading level. If I was still having difficulty, I asked for it at a Year 8 reading level. I validated the information that it gave me by checking it against my existing understanding, by comparing it to what Haziq had said and to the articles that I've been reading about ChatGPT, and by reading a few Wikipedia entries. One piece of information was wrong. ChatGPT gave me an unsophisticated and inaccurate definition of disruptive technology based on what those two words mean in isolation, not as they were used by Clayton Christensen. I generally rephrased ChatGPT's output so that it felt natural for me to speak, and I added my own thoughts and comments. Except for one small section where I read it exactly as it came out of the AI. Did you notice it? If you think you can spot it, email me, and if you're right, I'll send you a prize and a recommendation letter for your next job at Turnitin. I hope this has helped you to understand how AI technology works, the implications it has for the ways that we do business, the impact it might have on our lives, and the importance of understanding its limitations. Thanks for watching.